Complex numbers part 2. First one is standard form. The second one is polar form, and the third is exponential form. Exponential form is the short form of polar form, where r is equals to root of x square plus y square, and theta is tan inverse y upon x. These are the some values of tan theta that you should know. Polar form for different signs are as follows. When x is greater than 0 and even y is greater than 0, the point lies in the first quadrant. And then the theta values to tan inverse modulus y upon x. When x is less than 0 and y is greater than 0, the point lies in the second quadrant, where the value of theta is pi minus tan inverse modulus y upon x. When x is less than 0 and even y is less than 0, the point of the polar form lies in the third quadrant, where theta is pi plus tan inverse modulus y upon x. And the last one is when x is greater than 0 and y is less than 0, point lies in the fourth quadrant, where theta is 2 pi minus tan inverse modulus y upon x. If there is a negative number in the modulus, the number comes as positive. So you don't need to study the negative part. You can just go with the positive part of the tan theta table. Let's solve one example. Express the following complex numbers in polar and exponential form. For example, if my complex number is root 3 plus I, which means z is equals to root 3 plus I, you can compare to the standard form of complex number where x is root 3 and y is 1. Now you have to find r. So what was the formula for r? R was root of x square plus y square. Put the values in the bracket. You can see that square of root 3 is 3 and square of 1 is 1. Then root of 4 gives us number 2. So the value of r is 2. Now we have to find the value of theta, as we know that x is greater than 0 and y is also greater than 0, which means both are positive. The point lies in the first quadrant. And we know that in the first quadrant, the formula of theta is tan inverse mod y upon x mod, which means mod of 1 is 1, mod of root 3 is root 3. And when you go back to the table, you can see that the value of 1 upon root 3 is pi upon 6. So therefore, the value of theta gives us pi upon 6. Now, as we know the value of r is 2 and theta is pi upon 6, we can put this values in the equation of polar form and then exponential form. So what was the formula for polar form? It was z equals to r multiplied by cos theta plus I sin theta, where theta is pi upon 6 and r is 2. And hence we got the polar form. And the same you can do with the exponential form. The formula for exponential form was z equals to r into e raised to I theta. So just put up the value of r and theta. Important point to be noted over here is that the value of I, whether it should be positive or it should be negative. Now you have to see the polar form. If in the polar form the value of I is plus I, then put plus I in the exponential form. But if it's minus I, then you have to put minus I in the exponential form. Now you can solve different sums based on polar and exponential form following the same method. Hope you like the video. Follow for more.